Hello, this is Captain Chaudhari. In my today's video about the basic stability calculations, we'll be taking up a case where the forward part of the ship or the aft part of the ship is damaged, and we need to focus on that particular draft, that particular area of the ship which is damaged, and we have to bring that portion above the water, right? So that temporary repairs can be done, right? So let's take a case where the ship's length is say 160 meters, LCF say 75 meters, TPC 28, and MCTC 260. After damage, what happens is the ship sinks to a draft of 9 meters forward and 7.4 meters aft. Now we need to bring the ship to a draft of say 8 meters, right? Forward draft to be 8 meters, so that the damage comes above the water and we are able to do some temporary repairs there. So the question here is, now how much weight needs to be discharged? The location is 40 meters forward of center of flotation. Now how do we approach this kind of question? Like just to say the ship is like this over here, and the damage part is say over here. We need to cut down the draft to 8 meters forward, and by doing that we will be able to repair that portion. So I have been telling you, I tell the boys that draft at any point changes because of two basic reasons. One is bodily rise, right, and other one is change of draft purely due to change of trim, right? So we have a location that is 40 meters forward of center of flotation. From this position we need to discharge. So we assume that while we discharge these weights, the basic stability parameters like TPC, MCTC, etc., they don't change. Suppose we are discharging a weight of W from this location. The bodily rise would cause the drafts all over to change by an amount W upon 100 TPC. As I tell my students that draft at any point, while we do the trim questions, we must remember that draft at any point changes because of two reasons. You may consider them to be independent reasons. One is bodily rise and other one is change of draft because of trim change alone. So if the initial draft forward was 9 meters, the first change that we cause is bodily rise. And bodily rise is W divided by 100 TPC, that is W divided by 2800. So that is 1 divided by 2800 gives me 0.00036. 0.00036 W. So this is the change that is caused forward because of bodily rise. Now, because we have discharged a weight of W at a distance of 40 meters, it is going to cause a trimming moment that is 40 W, and it is going to change the trim, that is TRC is going to be WD upon 100 MCTC. That is going to be 40 W divided by 26,000, because MCTC is 260, so that is 40 divided by 26000 gives me 0.0015, that is 0.0015. 4. So many meters. But this is the trim change, and the change of draft aft because of trim change will be given by this formula. TRA is equal to TRC into LCF upon LBP. So TRA is going to be TRC, that is 0.00154 into LCF is 75 divided by 160. So this is going to be 0.00154 into 75 equals divided by 160 gives me 0.00072 meters. And we know that TRF is equal to TRC minus TRA. So this will have to be subtracted from 0.00154. This gives me 0. That is the TRF is going to be 0.00082 meters. So we have equation now that initial draft we start with 9 meters minus 0.00036 and TRF is going to be negative because we are discharging from forward and ship is going to change the trim aftways. So also minus 0.00082, that should be 8 meters, which means that when we subtract this quantity from 9 meters, it should give me 8 meters. That means this quantity should be 1 meters, which means that 0.00036 plus 0.00082. Of course, I have to put W here. So the equation which I have is 0.00118 W should be equal to 1 meters. So W should be equal to 1 upon 0.00118. Let's see, 1 divided by 0.00118 gives me how many tons? Gives me 847 tons. So 847 tons, 847.4 tons is to be discharged from this location 40 meters forward, so that the trim of the ship would change in such a way that the forward draft will become 8 meters. So these kind of questions, what we do is we follow the basic principle that the draft at any point is going to change because of two independent reasons: bodily rise and change of draft because of change of trim. So we start with the draft 9 meters, apply bodily rise to it, and apply change of draft because of change of trim, that is TRF, and we should get the final draft that is desired, that is 8 meters. So the similar calculation can be done for a position if we have to load at this point. If we have to load at this point, what will happen is there will be change of draft at forward point because of trim change as well as bodily sinkage. Bodily sinkage will be positive and change of draft due to change of trim will be negative. So a similar calculation can be done, similar equation can be done for a position forward or a position aft for loading as well as discharging. But of course, if we are loading, it cannot be done forward of center of flotation. If we are loading, to get the draft to 8 meters, we'll have to do the loading only aft if it is possible. So we know the forward draft is going to be 8 meters. We can also find out what is the aft draft. In fact, we can find out what is the final fore and aft draft. And for that, I advise the students to go for a standard procedure, and that I call standard trim format. We start with the forward draft. We start with the initial drafts. Forward 9.000, aft 7.400. Now, in the first leg, we will apply bodily rise. We have discharged 847.4. So 847.4 divided by 100 TPC, that is 2800, gives me 0.303. 0.303. 7.097, 8.697. Now the trim change is caused because we are we are discharging a weight of 847.4 from a position 40 meters forward of center of flotation. So the trimming moment is going to be 847.4 multiplied by 40. This is the trimming moment that is caused. To find out what is the trim change, trimming moment has to be divided by 100 MCTC. That is, it will be divided by 260. This gives me the trim change equal to 1.3037. 1.3037 is the trim change, and this multiplied by LCF, that is 75, divided by LBP, that is 160, gives me the TRA, that is a change of draft aft because of trim change alone. So 0.611. Because we have discharge from forward, the aft draft is going to increase, so this is going to be plus, and if this is plus, TRF is going to be minus, and that is going to be minus 1.3037, because TRF can always be found by TRC minus TRA. Total trim change minus TRA is going to give TRF, that is 0.693. 0.693. So let's find out the final drafts. Here it will be 7.708, and here it's going to be 8.004. So this is how we can find out the forward and aft draft, by the standard trim format.